Yeah. Okay. Hello, Chanchal. How are you? Amazing. All right. Now, for your lab last day, okay? Some of you in grade 11 probably never even looked at your lab manual as a pre, this introduction. But for this particular lab, it's going to be important for you to make sure you read the introduction, because if you look a little bit further down, come on, okay, what happens is about halfway down, what you will see is you will see the information for part 1, part 2, part 3, and part 4. Okay? It will give you the formula and it will give you the background information. Okay? Now, if you take a look at the very last page, there's this thing called the post-lab considerations. When you read the post-lab considerations, that gives you the information on how to fill in your data table. Okay? Now, what I'm going to ask you to do right now is, can you get out your lab? And also, can you get out your data table? Okay? Now, when you get this lab, remember I said I wanted you to just record the color. So what you should have gotten was color observation. Should have went green, the yellow, green, the blue. Okay? Now, how do you fill in this direction of equilibrium shift? And how do you fill in the stress ion? Well, you have to go back to the equation. Now, the equation for part 1 looks something like this. Bg is Bromkessel green plus H plus gives you Bromkessel green, yellow. Now, you might say, some of you are frantically copying this down. Mr. Chan, where did you get this information from? It is from right on the first page. Right here. Bromkessel green, blue, and H plus. All I did was I just flipped the equation. The Bromkessel green with H plus is on the right-hand side. The Bromkessel green, the yellow, is on the left-hand side. All I did was I just switched it. Bromkessel green, blue, and H plus is on the left side. Bromkessel green, yellow is on the right side. Okay? Now, what was the original color of the Bromkessel green? Did you folks report that color down? What was the original color? It was blue. So the original color was blue. Okay? Now, it went from blue to green. So which direction did the equilibrium shift toward? Did it shift, in this case, towards the product, or did it shift towards the reactant? Right? If it is going from blue to green, did it go in this direction towards the door, or this direction towards the window? Towards the door. Very good. it went towards the door. Hey, it went from green to yellow. Which direction did it shift towards? Towards the door some more. In this case, the fourth step, it went to green. So which direction did it shift towards? Towards the reactants. That's right. Towards the reactants. Because it went from yellow to green to blue. So if it started at yellow, it went to green, which is halfway, blue even more. Does that make sense? If you started with blue, it went to green. Does that mean you're going more towards that direction or more towards yellow? More towards the yellow. And then you went from green to yellow, so that's even more in that direction. You good with that? Okay. Now, the second thing, what is this stress ion additive? What is the stress ion? Where do we figure it out? This is where you read the post-lab discussion. So can everybody take a look at lab 12A? And let's look at the post-lab discussion. Okay, right here. Okay. This is in your book. Okay. So it's good to follow along. Leo, can you read the first paragraph here? It's in your post-lab discussion. Okay. Reagent. Concentration. Okay. You read it. Some of you might say, what does that mean? Okay. So let's take a look. Seriously? All right. For those of you watching after, this is Kasea like cracking her elbows, like going snap, snap. Okay. This is on record. It's now people watching this video. Yes. All right, because there are some people that are not used. All right. So what does that mean? So when you take a look at this data table, why did it change color? Now, HCl. Is HCl an acid or a base? Acid. So when we just read, what does an acid provide? Leo, you just read it. What does an acid provide? You just read it. Somebody can help them out. Are present in acids. You just read it, people. This ain't Google. This ain't swipe right, swipe left. You actually have to read. Okay? So in this case, H plus ions are present in acid. So what must have been the stress ion? When you added, what must have been the stress ion? H plus, right. And how do we know that? Is because H plus is in the equation. How about this one? Step 4. What else did we add? It's an acid, so what's the stress ion? H plus. Okay. Now, step 5, step 6. NeOH, it's a base. In the post-lab discussion, what does a base provide? OH ions. Now, you might say, well, Mr. Chan, why does it shift to the left? Because what does the OH do? In the last sentence of that paragraph, Kasea, can you read the last sentence of that paragraph again? And what does the OH ions do? Removes the H plus. So what happens is, why does the equilibrium shift to the left? Because the H plus concentration is reduced by OH minus 1. You are decreasing your reactants. Equilibrium shifts towards the reactant. This is Le Chatelier's principle in real life living color. What is Le Chatelier's principle? Oh my, it's this thing, remember? The water. Okay. Now, for part 2, this is the equation that you should be aware of. And this was the results that you should have gotten. You can double check. Okay? Okay? That's the result you should have gotten. Now, you might say, well, Mr. Chan, what do you mean by darker, NC is no change, lighter and yellow with crack? What do you mean by that? Well, I took a picture of one of your results. When you did your lab, this was the original. Okay? Your second, third, you would have noticed was a lot darker. That's test tube B, test tube C. Test tube D, notice it's almost exactly the same color. Test tube E, it turned really yellow, but it was a cloudy yellow. Hopefully you folks noticed that. Some of you are like going, I didn't notice anything. Okay, that's what I mean by yellow with crack. There's like little stuff floating around. Okay, now, again, when you take a look at your data table, you might say, well, Mr. Chan, how did you get this equation? How did you get this Fe plus 3 plus SCN minus 1 gives you Fe SCN 2? Where do we get that from? The front page. Thank you, Adrian. Right here. Okay. So we flip through it. It's right here. Now, it says a light yellow iron and a colorless thiocyanate ion. They react together to form a compound which exhibits a blood red color. So from that sentence, we know that the FeSCN is red. So in this case, when you look at this table, you know this is red. And I wrote it in blue. Okay. Now, so let's redeem ourselves, you people. The first one, it got darker red. So which direction did the equilibrium shift towards? To the Beyonce or the anti-Beyonce? To the left, to the left. Anti-Beyonce is to the right, to the right. Chantal? To the left? To the right. Correct. Thank you. Well, you better if you're driving. Okay. That's okay. At the red light, yeah. Left, yeah. Okay. I told you the joke, right? One of my, I used to have a tenant that lives downstairs. She hated turning left. So what she would do is she would do 3 rights. So do 3 rights to turn left. So I told that to my son. I said, you can do 3 rights to get a left. You can have 2 wrongs to get a right. So that means 6 wrongs would be equal to 1 left. Think about it. 2 wrongs make a right. 3 might make a left. So, okay. If I have to explain it, that sucks. Okay. Now, for the second one, it got darker. Chantal, to redeem yourself, which correct. Now, let's jump to the last one. We got yellow. Which direction did it shift towards? Correct. The third one, no change. There should be no shift. Okay. Now, if we look at this, looking at this particular I equation, for the first test tube, which one must have been the stress ion? The K or SCN? The K or SCN? SCN. Why? Is because there's SCN in it. Make sense? Okay. So I've increased my reactant, equilibrium shift to the left. Now, how about the second one? FeCl3. FeCl. Which one is it? Fe or Cl3? Sorry? I can't hear you. Fe, very good. Again, because there's Fe plus 3. Oh. The reason being is because FeCl3 breaks up into Fe plus 3 ions. Okay. Now, KCl, there is no stress. Why is there no stress? Is because there's no K or Cl in the original equation. Okay? There's no K or Cl in the original equation. Now, but in this case, the last one, Mr. Chan, there's no Na or OH there at all. How can you have an equilibrium shift? This seems to contradict. Well, this is where you need to read a little bit further in the post-lab discussion. So if you look in the post-lab discussion, you'll be flipping through this back and forth. Okay. It says here, may I get Isaiah? Oh, you can read it again. Okay. In step 8, it's right there. This is for what happens when you crack your elbow. Okay, so notice FeOH3 was produced. So in this case, what would be the stress ion? The stress ion would be OH minus 1. Why? Is because the OH minus 1 will react with the Fe plus 3, okay, to form a precipitate. So if the OH minus 1 reacts with the iron, the concentration of iron goes down. And which direction will the equilibrium shift towards? It will shift towards the side of the reactant. Okay. This is your lab where you actually have real life data. Okay. What I'm going to get you to do for the next maybe about 20 to 25 minutes before we take a break is I want you to try. What? Okay, what did you not finish? Part 4. I think you guys didn't finish part 4 either, right? So maybe the 4 of you can join up together to do part 4. Okay, and I have the chemicals on the side. Okay, so some of you didn't finish the lab. Okay, some of you did. Okay, some of you just came in here. Okay, then you might want to join up to see help them out. What I'm going to ask you to do is this. As part of your homework for this lab, I'm going to ask you to do question numbers. Actually, yeah. Yes, it is. What I would like you to do is numbers 1, 2, 3, 4, 5. Okay. I'm just going to say 1, 2, 3, 4, 5. That's all I want you to do. Okay. Actually, and number 7. Yeah, number 7. Okay. Now, so 1, 2, 3, 4, 5, and 7. Hint, 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 hint. There will be lab-based questions on your test after Victoria Day. Okay? There will be lab-based questions. So you should know what's going on in the lab. Okay? That's for you to be aware of. So you might see a question similar to one of these. Okay? So for the next few minutes, so about 20 minutes, you can be working on the lab. Or what you can be doing is, anybody else want to finish the lab? Right. Okay, I'm going to grab another set. So you're doing part 4, right? Part 4. Okay. So one set here. Okay. So you can work on that. If you got the lab done, you can work on filling in the entire data table and working on the question. Okay, ladies and gentlemen, you have that for the next 20 minutes until we take a break. Oh, so sorry, I gave you that. Let's switch. Sorry? Yeah, of course.
I know. Yeah.
Okay, if you haven't finished part 4, I have Leo, I think he's there. There's one set, and I am the second set for you. Okay? So Sharon, you can work this time to finish it off. So this is why.